Hi, guys. Thanks for joining. This is Essence of Medicine, and today we're talking about the nervous system. I'm Amanda Armagost.
And I'm Dr. Abbasi for Essence. Wow, what a topic.
I have been learning a lot about the nervous system in the past week. Just so everyone knows, I am taking a 200-hour yoga teacher training certification, but in addition to that, I'm taking another class. It's actually laughter yoga training. So soon, yeah, that is actually how you do it. So soon I will also be a laughter yoga practitioner.
And I'm going to tell you why it does work. Go ahead.
And it does. That's why part of why I wanted to talk about the nervous system, because I've been learning so much about it. I do have a few questions, but I am going to tie in my little hippy dippy airy fairy stuff into the medical side of things.
And I've been dealing with the nervous system, not in the last week, but in the last, I would say, probably 35 years. So I have some knowledge of the nervous system because I'm as a neurosurgeon, that is what I work with, the nervous system.
It's wonderful. And I am very good at regulating my nervous system. So
I'm very good at and knowing what we know about that, the extent of our knowledge about the nervous system. Mm-hmm. So, where should we start?
Well, stress and the nervous system are very closely connected. So I just want to start with something that like everyone can relate to is how does stress impact your daily life, which we have talked about before, but I want to talk about it more like how does it impact your nervous system and why is that impacting your life and things like that.
Mm-hmm. Well, that's such a specific thing. Now, the concept of stress only applies if you have a nervous system.
Which every living being?
Well,
like, no, would you say that molecule?
Okay. No, I'm going to take it back, okay? Now, there is a stress that you as a human understand. Like, when say I'm stressed and so on. That concept, what people understand under stress, applies only if you have a nervous system. But there is a biologic sense of stress that applies even to one cell organism without nervous system. That is a situation when, like, for example, we have actually some protein that counteract effect of the stress, meaning that, like, imagine there are this bunch of bacteria and temperature goes all of a sudden to 50 degrees. The form of the protein change, and that is what we call a heat stress. And then there are some protein even at that level that are based on you are as a living organism going to be in that situation. So I'm going to make a protein that goes back and turn those molecules, those proteins back the way they were supposed to be after they are deformed because of the heat shock. And we call them heat shock proteins, where they go and return them to the original state. Now, what you understand under stress is about like what we as humans go through. And guess what? If we didn't have our brain and nervous system, we wouldn't feel that stress.
Yeah, but if we didn't have stress, there's a lot of things we wouldn't, like we need a little bit of stress. But sorry, I want to talk about those proteins. When you say proteins, the way I understand proteins is like what is in eggs, what's in chicken, stuff like that. Can you elaborate?
Oh my God. Okay. I'm going to go 4.3 billion years back now. We are in the primordial Earth. There are lots of different molecules, lots of different things. Now, the meteor bring stuff from the sky. There are lightning. There's lots of primordial soup. And all of a sudden, a protein, or not a protein, a molecule appears that has the possibility to replicate itself and use energy. Now, that molecule is actually an RNA, is a ribonucleic acid protein, like a chain of that has a shape. It has two properties. It can replicate itself, and then it has another property. It can act on what's out there and take that source of energy from molecules that are around it. So it can use the energy and it can replicate itself. Boom, you have life.
Okay.
Fast forward just about 300 million years later, that molecule understand, okay, I can do replication and I can do enzymatic activity, but I'm not good at either one. Let me cooperate to two different group of molecules. DNA that can be so much better at replication, and guess what? I can get the information from DNA, make another chain of molecule, proteins, and hey, look at that. I have this amino acid. These are molecules that they're monomer, but I can connect them together, make a longer protein that then it folds, and then it becomes like a tool. Imagine that you have a bunch of Legos that you can put together and build a wrench.
Okay, yeah.
That is what the protein is.
Okay. So where are these proteins?
But the information, how would you connect those Lego pieces together, comes from DNA through RNA. It becomes then protein, and now all of a sudden RNA said, I have done my job. At first I was there, and this is the new knowledge we regain. At first RNA that's our current understanding. RNA was the first kind of life it existed, but it wasn't as good as protein in enzymatic activity, but it wasn't as good as DNA in replication. And now we have life based on DNA, RNA, and protein.
So where are these proteins found, these heat stress?
So now imagine you made your protein is for your structure. Like what's holding you together right now is your proteins. Like your connective tissue, your muscle are moving you. The inside of your cells, those enzymes, those basic molecule of the life are proteins. Okay, so the rest is, even in your bone, if you take all the calcium away, you have a structure of protein. The calcium comes and give it strength, then it becomes bone. But protein is everything that makes your structure and makes your enzymes that literally do the metabolism in your body is made of protein. Now, each protein works best in certain temperature, certain environment, acidity, and certain overall density of other molecules around it. They have the optimum. If you take them out of their optimum, like one of the normal way to give this protein stress is increasing the temperature.
Okay.
And then we call it heat shock. Okay, and then once you are there, it changes the form of the protein, sometimes irreversible, sometimes reversible. And there are some molecules that can help. Now imagine this molecule now is a protein. I go to 48 degrees centigrade, it changes. If I come down, it changes back. Now I go to 50 degree. It changes, but it's locked in now. It cannot come back. But the other protein comes and helps it to come back. And then you go to 55 degree, it changes and it never comes back. That is why when you heat milk, the taste changes.
That's kind of interesting.
To a certain degree.
Right. That's kind of interesting because same with humans. Sometimes when we have stress, it has these it impacts our body in certain ways, and a little bit of stress can impact us and we can go back to equilibrium. But sometimes if we have too much stress, it impacts us to a place that we're not able to go back.
And what you're referring to, stress at the human level, it produces truly stuff, material that take our body out of its optimum configuration. Now, certain level of stress is good because our system is always ready to deal with that. And it is like exercise. You need that.
Yeah.
But the problem is the chronic stress.
Yeah.
Okay? Chronic stress is something specific to human. Like the gazelle or the deer being chased by panther, it either get eaten or get away. But then stress is gone.
Yeah, once it gets away, its heart rate goes back down pretty quickly,
Rapidly,
right?
yeah. Or it get eaten, then the heart rate goes really down.
Yeah.
Okay, but in our society, like you have a problem at work for months and months and years and so on, it just doesn't go away. That imagine the gazelle is being chased
24/7
for years,
Yeah.
and now you have a human
Well,
problem.
and then also, like, the thing with humans too is sometimes we even have stress in our dreams,
Okay,
right?
yeah, obviously.
I've had dreams that are so stressful I wake up from it.
Oh wow.
Yeah.
So, but we're still talking about nervous system, right?
Yeah.
So, nervous system, that kind of what you are talking about can truly change the chemistry of our nervous system. And certainly we know that people have chronic stress. They have higher rate of many different problems like amnesia. I'm talking about nervous system, dementia, forgetfulness, short temper.
So heart disease isn't connected to the nervous system?
Well, heart disease can be connected to nervous system indirectly, but not directly. That is a stress does cause heart problem.
But your stomach issues are connected to your nervous system, isn't that true?
It is, but that's a different nervous system. There's something we didn't know, and in the last 10 years, we call it our second brain. That we have, it's told that we have as many neurons in our GI tract as we have in our brain. Meaning that the environment of our GI tract is just, there is a nervous system from our tip of our lips all the way down to our anus that goes along the GI tract and controls, regulated. If you don't have a regular, normal control over it, but like I'm sure you have heard that if lots of kids, actually there's a joke, they say if the parent knew what goes in and out of their children, they would be scared to death.
Never heard that.
Well, we say that in German.
Okay, well,
can you elaborate? What that means that, the kids, like they eat needles or sharp stuff and so on and so forth. And our GI tract, whenever something sharp comes to it, it relaxes and it turns the needle along all the path. Like lots of kids actually swallow a needle. It comes and goes out without really damaging them, doing too much harm to them, because there is this brain around our GI tract that takes that sharp needle, guides it along our GI tract all the way out. Imagine in the nature, kids are going to eat dumb things.
Oh yeah, well, my dog eats like toys all the time.
Yeah.
So our GI tract's nervous system and our, what would you call our central
nervous system,
are they communicating to each other? Or are they kind of on their own?
They communicate mostly with hormones, but there are two. So let's go talk about nervous system. We have so-called central nervous system, and then we have a peripheral nervous system. This is the location. Our brain and spinal cord we call central nervous system, and all the nerves that go out we call the peripheral nervous system. Then we have so-called automatic or what we call unconscious part of a brain and conscious part of the unconscious part of the nervous system and conscious part of the nervous system. The what we call automated or unconscious part of nervous system, we have two systems. We call it parasympathetic and symptomatic.
Symptomatic and parasymptomatic
nervous system, okay? And those are in harmony. They control most of our GI, blood pressure, heart rate, and so on and so forth. And we call them unconscious, but just in the last maybe 40 years, 20 years, we understand that we can consciously actually control them. Like, like your heart rate is under control of your parasympathetic and symptomatic nervous system. And we never thought that we can consciously reduce our heart rate or blood pressure.
Mm-hmm.
But if you give people visual feedback, like you beep on the screen or you have a bar going up and down, and somebody concentrate on that, we have shown that actually our conscious mind can control way more than we thought it could.
Yeah, even with breathing techniques, you can slow down.
Obviously, meditation.
Yeah, meditation. Yeah, but also in my classes about laughter yoga, I've been learning so much about the facial muscles and how your facial muscles actually directly connect to your nervous system, in the sense that when you're smiling, even if you're not really smiling, you're faking it, your body thinks that you're really smiling. So it's not like, the way I visualize it is, it's not really communicating with your emotions in your brain saying like, are you happy? It feels you smiling, so it's like you're happy. And then same with laughing. Even if you just pretend to laugh, it doesn't have to be genuine. It will calm you down a lot.
And eventually it will become genuine.
Yeah.
That's an old saying, fake it until you make it.
Yeah, or the saying I just posted on my wall, you probably haven't seen it yet, is the more you laugh without reason, the more reasons life gives you to laugh.
Yeah, it's a good wisdom. Now, on the nervous system, that actually, there's a mechanism that's called mirror neurons.
Mm-hmm.
Like, literally, that they have done a study with monkeys. Imagine a monkey has a good method to climb a tree and get the juiciest fruit, which is good for the monkey. Yeah. The monkeys who can do that can survive better, reproduce more.
Yeah.
Or male monkeys who can do that are more preferred by female monkeys. So it's a good thing. Now, imagine our nervous system, especially in primate, has developed a method to learn things from just seeing it. So we have the so-called mirror neurons that if a monkey sees another monkey do something, it activates almost the same neuron that the first monkey needed to activate to get the job done.
Mm-hmm.
So what that means with short terms, which is deep, this is really deep, that just by looking at one monkey look at the other monkey doing something, this monkey is training itself to do the same job.
Just like going to a comedy show and being around all the people laughing makes you laugh. Watching a funny movie makes you laugh. And even though you're maybe not laughing, you still feel better and feel a little bit positive feelings from watching these people doing it.
Yeah, and I think that is evolutionary one of the reasons why we have movies, theater, and all of those things, because our mirror neuron can take the experience of what we see and create the whole same feeling or path in our brain. And that is why, laughter is like contagious. Mm-hmm. When you see somebody laughing, you start laughing.
Yeah, you have to laugh.
Yeah, and obviously, we associate laughing with good experiences and good feeling and so on. And it's a social bond that when you and I are laughing, we are not going to kill each other. Well, maybe not, at least not when we are laughing together. Now, you may be laughing and then you're stabbing me and so on. No. What I'm trying to say that, especially in social animals, laughter, comic relief, and so on, are considered good experiences. But how do we express that to each other? By truly, your good experience is inside of you. Mm-hmm. The only way I can experience your good feeling is through certain external kind of behavior, which is laughing.
Yeah.
And face, and so on and so forth. Now, if you create those experiences on your face, even if inside you're not laughing, and if you do it right, there are actually ways to say that, like the real laugh is with eyes. And so on, and so on.
You
and
can,
so,
you
so
can
there are ways,
practice that and make it too. Though.
but more or less, when you convey those external clues, my mirror neuron repeat them inside of me.
But it goes the other way too. If I'm showing you angry cues, upset cues.
Absolutely.
Yeah. I like to tell people that emotions are like a perfume that you can't get on someone else without getting on yourself.
Yeah, well, and the mechanism of how it's done actually is neurophysiologically well understood. And again, that's one of the deepest knowledge we have now about this so-called mirror neuron and what makes us human. And so, and imagine now you activate those external clues in yourself. You're sad, but you start just laughing, and in a way, your own mirror neuron,
you trick yourself.
You trick yourself, and that is the amazing part of that this laugh therapy actually works.
It actually does work. I'm learning it from the person who invented it.
Oh, wow. You met the person who invented laughter?
Well, the guy who, he like popularized laughter therapy. He was really depressed and he was having a lot of issues. So then he started laughing and doing stuff like that. He's an Indian guy. He's the one who pretty much invented it. But you can actually regulate your nervous system through nature.
Okay.
There's a lot of studies that are coming out right now that show listening to bird sounds and being around birds can help to calm you down and help to regulate your nervous system. So even like taking a 30-minute walk, no music, no audiobooks, just listening to the nature has a huge impact on your physical body.
Okay, well, there is actually a very good study, and there's a deep background to that. Our nervous system, it controls us, it protects us, it makes us survive, and so on. And over the millions of years, we have built this ginormous machine that help us to navigate in life. Okay, what you're describing is, I want to tell something that is as well very deep. When I say you park, like recreational park, what do you imagine? Tell me what you imagine if I tell you, or when I tell go with your dog, go with Lily for a walk in a park. Imagine that park that you and Lily are walking, and describe it to me.
Open spaces.
Number one, open space, yes.
Yeah. For sure, greenery.
Green, okay. Yeah.
Even if the grass isn't green, usually at a park, like a lot of times there's actually sandy parks that you can go to, but then they have plants along the area.
Short plants.
Variety of plants. Short plants and tall plants.
Open space, green, variety of plants. Okay, what else?
Animals.
Animals, yes. Okay, well, nature. Obviously.
Okay, when I say nature, I mean like bird. I don't mean dogs when I say animals. I mean like birds, squirrels, chipmunks.
Okay.
What else do I think of when I think of a park? Trash cans, so there's no garbage. Also benches, places for you to chill out.
Okay.
A lot of times parks have like a community aspect, so they have grills, places to hang out.
Okay, well, then you have community.
Yeah.
Okay, what else?
Sun, so openness.
Okay, openness, sun.
A lot of times there's water. Water.
That is what I was looking for.
Okay, here we go.
Do you know what you just described?
How we used to live?
Serengeti, but the life of the primate, the humans started living.
Well, think about this. This is something I think about a lot. So we like always want to separate ourselves from nature. We want to work in an office. We want to have a home, a roof over our head. But what do? We prioritize big windows. We want to be able to look outside. We simulate the sun. We have lights above us. We bring plants inside, fake plants, real plants, it doesn't matter. humans are so wanting to be with nature, even though they want to be comfy. It's like we're always going back to these little roots.
What you just described is the root of being not being stressed. So let me go one by one. You started with open space.
Yeah, that's very stress relieving.
Okay, imagine a group of humanoid 10 million years ago, 2 million years ago, somewhere between monkeys and human, they are in an open space. They can see from far if predators are coming toward them.
And then there's the variety of plants, so then they can hide.
They can hide, but this variety of the plant help them to hide or in low or go up and so on. And then light.
Yep.
They can see.
Yep.
Okay? They can see. What else did you say? It is
other animals.
Other animals. It's Serengeti because other animals is a source of food for them.
But also other animals are a source of safety for them because a lot of times animals know each other's calls.
Yeah.
So they like certain birds, yeah.
So they and maybe the lion attack the other animal instead of them.
Yeah.
If they start running, then they know something's wrong. Right. But it's a source of less stress because there is lots of alarms there that tell them something is not right.
That's why fish swim in schools, right? To limit the.
Let's stay.
No, but isn't it? Don't fish swim in schools to limit the likelihood that they get eaten compared to.
Well, that is in fact that the school they are safest. Then so, and then you said about the water. Well, we need water,
but moving water.
Slow moving water.
Yeah.
That is in all the park. When you go, it's always there's a slow moving water because fast moving water is dangerous.
And still water is dangerous too because it's not as
yes, exactly. See, and then you talked about the community because
which we already talked about with animals a little bit.
But that is the community. You and the other people in your group that are living together there. You have a campfire if you're at the time that there is a fire, and so on and so forth. So you see, we have carried that feeling of being distressing ourselves and our nervous system to say, relax, you are not going to be eaten, you are not going to be hungry.
Yeah.
We have been carrying that for millions of years from Serengeti to a park in Minneapolis, Minnesota.
Yeah.
We replicate our little Serengeti wherever we go.
Even at home, like you guys don't know what my living room looks like. I have so many lights, so many plants. My living room really does give the vibes of like outdoor windows.
Yeah.
And
so, what do we understand? Where is our anger center?
Anger is a secondary emotion. You feel anger because you're feeling a different emotion, and anger is like the manifestation of that.
Of being scared or being hungry, being hungry, being grumbling, being Amanda.
Okay.
So, anger. There's a small little piece in our brain.
The amygdala?
Amygdala, yes. It's actually when you go here, about 2 inches in my brain, there's a very small kind of accumulation of nerves called amygdala that we think that is what the source of anger center is.
Yeah. Don't some people, I think, have like an overactive? Didn't they figure out that sometimes people have an overactive amygdala?
We do know that some people have overactive amygdala.
Maybe some people have an underactive amygdala too. Do not get angry.
They're hippies. We know that the cannabinoids suppresses your anger and so on, and reduces your response in the amygdala.
Yeah, but what's the benefit of getting angry? Because obviously we're feeling angry. Like you feel angry for a reason.
Yes. Okay. Well, let's say. Have you heard cornering somebody?
Cornering? Yeah. I have 2 cats.
Okay, so what happens if you corner a mouse?
They'll attack you.
You're so much bigger than them, but they will attack you. They still do you because we have this so-called distance, fight and flight distance. in every species is different. And by the way, in every culture, that's as well different. Like, whereas Italian are just 2 inches from each other,
Germans want some space.
the Swedish people are like 2 feet from each other or more. So if you get into the fight and flight distance, at first reaction of every animal, every person is create that distance, go away, flight is first. But then when you come to another distance, the fight distance, so they cannot they cannot go away anymore, then they will fight back. Now, when you fight back, you have to, no, first of all, biology want to be safe. Being away from the danger is the first thing to do. But once it is truly a situation that there is no way to get away from that, you have to disregard everything else, like pain. You have to disregard every other aspect of the life except fighting for survival.
Yeah.
Like, you don't feel pain anymore, actually. You don't, and that is the function of being angry, is that you disregard everything, you suppresses your frontal brain. Like, no sound person would put a knife in somebody else. But in that moment, all the social norms are gone.
Yeah.
And you are at the point that, you think you're going to die, and you have to prevent that with all means needed.
And people with anxiety disorders, they're in fight or flight. And so sometimes I've noticed this from my experience, not about me, but about people I've been around. Sometimes they have anxiety and then their fight or flight breaks out and then they choose fight, and it's so unnecessary. It doesn't have to be fight, but because they are overstimulated and they have this anxiety and they're not regulated, they start fighting and being angry.
Often you will notice people who are very aggressive, they are very scared and anxiety-ridden people. It is exactly the same. At first, you're scared, you try to escape away, flight. Once you're saturated with fear and there is no way to escape, then it turns into anger and aggression. And we see it all along with all animals and so on and so forth. And in human, obviously, we see that in a very different variation that possible. And obviously, anxiety is a big deal. Lots of people have to deal with that, live with that, and literally, I have this. And lots of people have to deal with that, and that comes as well from our environment. That in nature, the gazelle goes away or get eaten and then can go back to regular life. Imagine the gazelle is now being chased for 24/7 for weeks, months, years, and so on. Okay.
Yeah.
Then those distance from flight to fight back, they become really fuzzy.
It's not enough time to go back to your, would you say it's equilibrium, your normal being?
Yeah, there is no equilibrium anymore. Yeah. Wow.
So what do you think are the biggest consequences on the human body of having a dysregulated or irregulated nervous system?
We die sooner.
Yeah, but there's some physical consequences too. It's not that you just die, drop dead. It kind of
we age. That is what aging is. We age faster.
We've all seen the photos of Barack Obama is who I have in mind, but the presidents, when they enter the office and when they exit the office, that really shows the effects of stress. Because they don't look like they aged 4 years. They look like they aged at least 10 years.
Yeah, well, with Barack Obama, it was 8 years.
Okay, well, they look like they aged double the amount of time.
Yeah. Well, that makes totally sense. And it wears you physically down, this effect of the stress. And it's not only your nervous system, it's your entire literally body, your skin, your muscle, your bones, and so on. But obviously, we are talking today about the nervous system. One of the ways to actually keep the nervous system active, or is that keep yourself stimulated. Our bodies generally use it or lose it, but our nervous system double, triple that.
Really?
Yes. Who we are is about few pounds of gelatinous material in our skull. That's who we are. Truly, that is your personality. Now, the number of the connection these neurons make together is you. And it is natural that those numbers fall down when we age. We have a vast amount of information now that we know that by just learning new things, having new experiences, and so on and so forth, you have more connection there. And more connection you have in your brain, synapses we call them, more robust is your brain, more agile it is, and it has a higher number because with aging, the numbers are going to go down, but you have higher number to start with. The number of the neurons are more or less, it always go down. As a matter of fact, that is one of the important things, when we are born, obviously, we have 40% more neurons than when we are teenager. But those neurons have a lot less connection, and they are not myelinated. That's how our brain grows. It's not because we have more neurons, nerve cells. Actually, we have less neurons, but they are well myelinated and they make connection. That is the maturity of the nervous system. Less neurons, but more connection, and those nerves are myelinated, meaning a sheet of fat goes around them. Guess what? That sheet of fat not only protects our neurons, but as well it makes them communicate with each other faster, because myelinated neurons, they are much faster by like magnitude of 100.
Okay.
Faster to communicate.
So you pretty much need to exercise, is what I'm hearing. Exercise your. How do you do that? Can you give some ideas for simple day-to-day things that someone can do at home? Reading.
Puzzles.
About puzzles, like mind games.
Anything. The new experiences. Travel. A new language.
Walk in a new park. Would that help?
Being in a situation that your brain. So, how many times do you go from home to work and vice versa?
I think about this a lot. I go from home to work, obviously 5 times each way, and I do not think about my drive at all. Sometimes I just wake up and I'm at home all of a sudden.
So, but imagine, all of a sudden in one of those things, there's a giraffe in the middle of the highway.
Then I would remember that.
You would always remember that.
Or when I take a new road, like where there's some construction kind of on the way to my house, so I had to take a different route, and I paid a lot of attention the first couple of times because I was thinking like, oh, look at this river. What river is that? Why is it so high?
Okay, so and those new experiences, they all are. Our brain lives for new experiences. That is what our brain is. It is a puzzle solving machine. It's a accumulation of neurons. They just want to say, what is going on here and how can I react best to that? If you are for 40 years driving the same back and forth and no new experiences, it's sort of you're starving your brain.
Yeah.
Okay.
I can imagine that being very numbing to have the same schedule every single day. You're going to the same office, the same home.
Now, yesterday, I was with Misha. By the way, congratulations, Noor and Misha.
Yay!
They just married yesterday, but we were in the courthouse or whatever it's called.
Sign the papers.
Yeah, sign the papers. And I was really proud of Misha. Misha was looking at the ceiling, seeing these foams. And he was asking me, what's that foam for?
Sound.
Well, actually, that foam is a protection against the fire. Because in a structure, in a metal structure, they have learned that if they put out like a 1-inch, 2-inch foam, that is kind of retardant. It makes that structure last 40 minutes more under certain fire and so on. But what I'm getting at you can sometimes give yourself
Yeah.
that experience. Like you're sitting here, you're seeing on the floor, you see pictures of animals walking and so on, or you look at the sky, all of a sudden clouds are a dog chasing a rat or something, and so on and so forth. So you see, our brain is always starving for new experiences. Sometimes if you don't give it, actually it start making shit up. Like then we get to this, all these people who are bored get into conspiracy theories and coming with some crazy ideas and so on. So what I'm getting, you ask me how to exercise your brain, give it new experiences of any kind.
Okay, and then so one last thing is, how can you calm, what do you think? I have, obviously, I have my own ideas. How can you calm down your nervous system?
Well, we know from the behavioral, there are medical ways to calm down your, like lots of medication that can calm you down. Ativan, Versed, Valium, and so on. They know exactly what they do in our brain to calm us down. But you're absolutely right. There are ways internally you can control that. Areas of the brain that we thought for a long time we don't have access. Now we know we have access to that. We can control it. Meditation, walks,
hanging out with your friends, just talking to your
positive experiences, and so on and so on.
Giving people compliments.
Yeah.
I think it's important to stop throughout the day and check on yourself about how your nervous system is feeling and maybe take any measures to calm it down in the middle of the day or at the end of the day or anything like that.
When you say that is a rhetorical question.
No, I'm actually asking if you think that that's valuable.
Oh, it's always valuable. It is like, the readjusting and recalibrating your nervous system.
Do you think it's necessary?
Well, I think we, at some level or another, we are doing it. Everybody's doing it one way or another, but
I do not think so. I think that there's some people, I know that there's some people who allow themselves to get very dysregulated and they don't have, first of all, the proper tools to assess themselves and say, how am I feeling? How am I behaving? Things like that.
No, I'm talking about you. You see, you and I are talking on two different words. You're talking about the more human aspect of it. I'm talking about the biologic part of it.
Yeah, but the human aspect ties into the biologic.
And the biologic part of it, it readjusts itself all the time. Otherwise, you would die. If you wouldn't, like your blood pressure and heart rate has to be in a certain range for you to survive. If our body wouldn't readjust, recalibrate, and regulate that properly, we would die.
And that does happen. People have strokes, people have heart attacks. Wouldn't you say that those are tied to people not regulating themselves?
Yeah, I'm going to cardiologist today, yeah.
So I think what I'm saying has a little bit of making sense that even if your body is going to naturally do that, you should still be
conscious about it and take as much care of it as you can. Yes.
So some tips that I personally have are, when you wake up, you should think about how you're feeling and what are you excited for. Try and give yourself some positive vibes right away in the morning. Start yourself off on a good note. And then throughout the day, checking on yourself too. Like maybe after lunch, you should take a 20-minute walk.
Oh, all good suggestions.
Well, thank you guys for watching. This was Essence of Science, and we talked about the nervous system. I'm Amanda Armagost.
And I'm Dr. Abbasi for Essence.
Have a good weekend.